Triangle go to prism. I don't know. I thought it was funny. So there you go. That's the joke of the day. Thought I had another one. Hello, hello. Geometry. Why did the 2-4s skip lunch? Did I do that one already? The 2-4s skipped lunch. Why? Because they already ate. Someone appreciated it, eh? Anyways, so let's dive in. This might be, to you, some of you, this might be like, really? Why are we talking about this? Because this booklet, to be honest, I created this probably after 10 years of teaching this course. So I know the mistakes that students tend to make. And so you are the first group that has like the revised version of this booklet where I'm like, I need to review this, otherwise I get lots of mistakes there. And symmetry, right? First of all, you need to know what symmetry is. Isosceles and equilateral triangles can be split in half, right? So isosceles and equilateral triangles can be split in half because they are symmetric. So if you're able to cut something in half and get identical halves, it's symmetric. This means that the length of the base and the top angle can be divided by 2. So often you have a triangle here, and you want to transfer it over, and this H stands for height. And we therefore are guaranteed that there's a 90 here, because height is always measured with a 90 to the ground. What else can we transfer? Like I'm obviously focusing on this one here. The 50 can be transferred, 50 centimeters. Right, so I'm just going to say this at the bottom here. This is an isosceles triangle, okay? Very important. It's an isosceles triangle. So we can take the 70 up here, divide it in half, and bring it over here. You can actually do that, right? That's 35 degrees. The 80 here, you can bring that over, but you need to divide it in half because 80 is from end to end. So this is 40 centimeters. Okay? So you've created a right triangle and you've transferred over information that is actually correct. Let's keep going. We could actually find this angle here because we've got 2 out of the 3, but I'm not going to do that just now. Let's keep going. I'm skipping, guys. I'm going too fast. Hold on. The reason we know that this is isosceles is, in this case, because of these numbers, right? They're the same. So we actually use, I'm sure you're familiar with it, but we actually use these markings. 1 and 1, that means that those 2 are the same. Okay? We don't know about the third. Actually, we know for sure it's not because of the 80, but we know these are the same. Okay? Keep going. One more. We see that all 3 sides of this particular triangle are the same, which means that you could actually go ahead and put these markings down like that. You could also do this. Watch. One marking at the angle is also correct because 3 sides are the same, 3 angles will be the same. 60, 60, 60. Let's put that down. That is actually true. Yeah, we know that for a fact. Equilateral triangle. It's also symmetric, right? So we can split this thing in half as well. No problem. Take the 60, we divide it by 2. We know that this is 30. This is the height of the triangle. There's a 90 formed here. We can take the 100, divide it by 2, bring it over here. That's 50 centimeters. 100 centimeter here comes over entirely. And so there you have it. It's yeah, actually, yeah, the 60 here, we can bring it over, yeah. Either using sum of triangle, or you just know that this 60 is the same here. Perfect, yeah, that's correct. Next. This is not, right, not symmetric, asymmetric. It's what we call scalene. Right? That's the name of a triangle where all sides and all angles are different. Okay? Let me already give you this is what's coming your way. We know that the numbers are all different. We could have done this. 1 there, 2 along this side, and then 3 along the bottom. You're saying they all measure differently. They all have a different length. Okay? So we could have done that without numbers, just with markings. And watch this. The angle across this one would be 1. The angle across this side would have 2 like this. And the angle across the third one, let's make that 3, right? So you can use either or, right? If all angles are different, all sides are going to be different, guaranteed. Okay. So what we cannot do, this is wrong, right? Let's make sure we write down wrong. You cannot go divide this by 2 and put 50 down here. This is wrong. You can say this is 90. Okay. You can say this is 70. This is correct. This is correct too down here. But you can also not divide the 100 base here by 2 and say this is 50 centimeters. That's also wrong, right? So these two are incorrect. Okay. That's wrong. Cannot do that. So if it's not symmetric, how do you know all sides are different or all angles are different? Don't cut it. Just don't do it because you're gonna make a mistake, right? You can, but you're not going to be able to transfer any information over. This is actually unknown, and that angle is unknown. There's too many unknowns there. Okay, keep going. I think I spent too much time on that. I think you already know how to do that, but while I do my attendance, I'm going to ask you to do that on page 3. I'm going to ask you to gather as much information on the left side that you possibly can. Put numbers down that you know are there. Then transfer stuff over to this one. And imagine the H, I will tell you that already, is here. And you transfer over to the right side. You can do that with just the first example or do it with both. Let's see how far you get. I'll give you a little bit of time. I would expect you to know how to do this at this point. But if you don't, we're not going to feel bad today, okay? We're not going to be like, oh, there we go, I just don't get this. We're not going to go there, okay? You can get it. It's just maybe you haven't taken math in a while. Maybe you didn't take math seriously before. Right. So I don't know if you noticed that 90 up here. Right, this is 90 degrees. These two sides are the same. So you can technically put money down on the fact that these two angles will be the same also, right? So we actually can say this is an isosceles triangle, and to be specific, particular, we're going to do more of this later. If you have a 90-degree angle, we actually say it's a right isosceles triangle. Very specific in naming this one. That's what we're going to do. That's basically what we're focusing on today, is naming them based on characteristics we see. So if you want to give this, a letter A, B, right? I know that angle A, this angle is the same as that one. So I'm just going to focus on this one for now. That would be 180 minus 90. Right, I need to divide that in half, right? So I take the 90 away, split the remaining amount in half. So that'd be 90 divided by 2, which is 45 degrees. I can add that to this diagram here, 45 and 45, right? So let's transfer stuff over. Is that right? This would be 90 divided by 2, right? This is 45 up here. And this 45 follows me. Everything else is unknown, right? So this is as good as it gets, right? So that's what I would expect you to do. You put in as much as you can. Next. Actually, sorry, one more thing. Because this happens in construction, it also happens later in the other problems. I'll say this about this particular case. If you split a right isosceles, you get another right isosceles. It's going to be smaller. It's going to be smaller, and you can keep doing that. Keep splitting, but you would keep on getting a right isosceles triangle every time. So keep that in mind. So if we split this here, always the 90 being where you start cutting, right? You would have two right isosceles, and then you split it again like this, two right isosceles, and then you keep going, and it would go on forever. Anyways, let's keep going. This one, I'm sure you recognize, right? That you were able to do that based on the markings, which in turn tells me without much further calculation, you just know that that's a 60 everywhere. This is an equilateral. Perfect, right? So that's what we classified it as. If this is the height here, we know that this is 90. We know that this needs to be split in half because you're cutting it right there. That's 30. This 60 can come with you here. This is 7 centimeters. The 7 centimeters there also split in half to get 3.5 centimeters. So I think you get the picture there. This one has a lot more information. You could use sine law or Pythagorean theorem. This doesn't look like a 3, does it? Yeah. Now we're talking. Okay. What's that? Oh, that's actually a good question because all sides are the same. We can take 180 and just divide it by 3. It's the only one that is like that. Yeah. Where's the 3 come from? Because there are 3 angles. So let's say this is ABC, all right? Angle A is going to be 180 divided by 3 angles, right? We're good? Always ask questions. If you feel like you need to ask questions, bring it, right? I might go a bit fast because I'm already hungry and I just want to go through this and eat. Right? I skipped lunch. Just like the 2 4s, skip lunch. All right, we're good? Here. These formulas you have to have on your study sheet if you feel like you're going to forget them. So I'm going to box this in. They come by all the time, all the time. Not right away, but they sneak in here and there. Like you might do an AC, it's like, hey, find the area of this, and you're like, what was the formula again, right? You need to have it on your study sheet. And I think I need to be very clear here that I don't have a diagram of a triangle because I feel like I did that already in when we did trigonometry. But the height in each of these cases always cuts through the shape, right? It's not a side of the shape, it cuts through the shape. Very important, right? Can I just tell you, I forgot to add that here, but there's this one. There's a trapezoid that looks like this. Sorry, it looks terrible, but it's kind of like this chunk is missing. It's called a right trapezoid. In this case, the height happens to be this, right? Like the side of the trapezoid is your height. So if it looks like this, then you're good to go, right? I will tell you one other thing. You might have to use Pythagorean theorem to figure out the height. So we'll cover that later on. It's definitely not just going to be like, here, plug in and go, right? You're going to have to do some work to get there. So add that to your study sheet after we're done here. Okay, PT, I call this for short. If you see Pythagorean theorem, from now on, it's probably just going to say PT. And I know you've seen this since maybe even grade 8 or 7. It depends on who your teacher was. But basically, I don't like ABC. I don't like to use those letters. I like to think of it this way, because letters kind of aren't always the same. C is always our hypotenuse, but what if it's not, right? So hypotenuse squared is leg squared plus leg squared. So obviously across the 90, that is always the hypotenuse, guaranteed. So the other two are called the legs, right? Does that make sense? I hope you follow. Pythagorean theorem only works with right triangles. Need 2 out of the 3 sides. That's the condition for that. So some students used it even in trig. Like when we did the trig unit, don't use Pythagorean theorem if it's not a right triangle, right? It's not going to work for you. So 2 formulas. If the hypotenuse is unknown, you go hypotenuse is equal to the square root of leg squared plus leg squared. And obviously I'm assuming that you're picking the 2 legs, right? The first one goes here, the first one there, square them, then take the square root. If a leg is unknown, you go like this. Leg is square root of hypotenuse squared minus the leg squared. I would expect you to know when to use which one. We're going to practice it a little bit just to make sure we're all on the same page. So I would say, right, if you need to add this to your study sheet, then go for it. But I don't do like Pythagorean theorem should only be like 3 lines and then you're done, right? And in my opinion. So here, let's practice it. You're looking at this triangle and you need to find that third side. It's a requirement, right? Not always will it be. But if that's the side, you find the 90 degree, you tell yourself, I don't care what that letter is there, I know that that side is the hypotenuse. Okay. Therefore, watch what I'm doing here. The hypotenuse is equal to square root of 7.6 squared plus 9.4 squared. This is leg and this is leg. Right? Those are my 2 legs because I identified the hypotenuse, right? And the hypotenuse is unknown here. So I go leg plus leg, square them, then add. Okay. So that will be, I like to have an intermediate step. So grab your calculators, 7.6 squared plus 9.4 squared. That's 146.12. So if you take the square root of that, that's 12.09. We are in centimeters, centimeters. I'm not going to clear my screen because I want to show you something. Check. I'm just going to put down under this that A was 12.08801, and I kept going. And I want you to be able to do this, right? Technically, Pythagorean theorem tells us that A squared is equal to 7.6 squared plus 9.4 squared. The hypotenuse is equal to the leg squared. So I'm going to substitute this in there. So we're going to go 12.08801 squared is equal to 7.6 squared plus 9. What's that? No, this is just to check. And I will explain what else we're doing here when you do something like this. It's based on construction. Okay, so if I square this, what's on my screen, I get 146.12. If you go 7.6 squared plus 9.4 squared, it's the same thing. So you know what you actually discovered? It is a right triangle. When you can figure out that the left-hand side is equal to the right-hand side, you actually are determining that it is a right triangle, that there's a 90-degree here. If this is not, if these numbers would not have been the same, it's not a right triangle. Okay, so I don't know if you talked about that. I'll just give you a quick. This is actually being used in construction, and some of you might be like, can I just go to sleep right now because I don't care? I'm not going to work in construction, Mr. Dirksen. So let's say this wall and this wall is framed. They're lying down flat, and then they lift it up and they match like that, right? So this is the wall there, and this is the wall there. So let's say this is 6 feet. This is 8 feet. They want to make sure when you're building and construction, you want to make sure there's a 90 at every corner. So what somebody does is they take a tape measure, they go from here to here, and they measure that. They measure that. And what does this measurement have to be? Well, Pythagorean theorem. They would go 6 squared plus 8 squared. That's 100, right? Take the square root of that. So technically this should be 10 feet, right? So they make sure that this is 10 feet. They use the Pythagorean theorem to make sure that there's a 90-degree angle there. So measuring the diagonal ensures that, like, if you follow the Pythagorean theorem, if you square this, you square that, and you square that, right? And this added up should equal to this side squared every time. Okay? Sorry. Information overload? Just forget about it. It's okay. You'll be fine. Once you use this, it makes sense, but sometimes theory doesn't always transfer very well. There's a 90-degree angle. Make this arrow and just tell yourself, That is the most important side you need to determine, because then you know the other ones are legs. Okay? So x, you're missing a leg here. That means that you need to take the square root of the hypotenuse squared minus the other leg squared. As simple as that. So you grab your calculator, you go 17.8 squared minus 12.6 squared, it's 158.08. Make sure you square root it, because it wouldn't make sense for your answer to be 158.08. That's 12.57 inches. You're done. You don't have to do the check every time. I just wanted you to see that. So there you have it. I want you to practice it before we move on. Okay? So go to page 5. The first two, I think you should have no issues with. The third one, it's a two triangle situation, so it requires you to do Pythagorean theorem twice. And watch this, guys. Hey, solutions are right here, printed upside down. So first do it, and then check to see if your answers match that. Okay? So let's take a couple minutes, because I need you to be able to do this. I'm not going to spend a whole lot of time on it, but I do want you to get it right. Okay? I think the first two, you got it. I think you should be able to do that. Let me just do C here with you. Always start with a triangle that has the most information, and then find the side that is shared, right? So I'm going to call this X. I know that this is the hypotenuse, which means this is a leg and that's a leg, right? So X is square root of hypotenuse squared minus leg squared. That would be root of 3,331.69, and I will make this probably, I will round this to 4 decimals. Why? Because I'm not quite done yet. If the question had asked for this in particular and then that, it's okay to round to 2 decimals and then round 2 decimals again. So in this case, this is the hypotenuse, right? So P is equal to square root of the 46.9 squared and this side, which is now a leg here, right? 57.7208 squared. You take that and you get 5,531.3. If you take the root, that gives you 74.37 centimeters. Same answer? Okay, sometimes it doesn't affect, sometimes it does, right? So just be careful there. So basically, this came in here, right? And you used it again for this triangle there. So, two-step. We're good? You seem so alive today, guys. I don't blame you. First day back. Okay, so this is where it gets to the meat and potatoes. Probably not brand new, but we need to classify triangles, okay? So all triangles, this is true. They have 3 sides, closed figure, sum of interior angle is 180. I forgot one. 3 angles. Okay, they all have 3 angles. There you go. Classifying triangles. When a question asks you to classify a triangle, you're asked to find the first and the last name of it. We can classify triangles by angle measure and by side length. So if you wanna name something based on the angle, there are three options: acute, right, or obtuse. And this gives it's a dead giveaway that it's a right triangle. Having either a diagram like this or something that's bigger than 90 here is going to be a giveaway for it being obtuse. And then you have your acute where everything is less than 90. So this would be the first name. Okay. Then you classify it by side length. So I will often say classify this triangle by angle measure and side length. This would be sort of like the last name. Okay. And there you have three options. I would add these charts. Well, I would make a very small chart, right? But equilateral, isosceles, scalene, sorry, for the three based on the side length. However, guys, remember the side lengths are very much attached to the angle. So the angle often gives you what it would be based on the side length, okay? So what can I say here? This one has two sides that are equal and two angles that are equal, okay? Equilateral, three sides that are equal, three angles that are equal. Scalene, what does it say? All sides are different and no angles are equal. Okay, let's go on the side here and just say all angles are not congruent. All sides are not congruent. What is that, Mr. Dyson? What? Kung fu, right? Congruent. Congruent means they're not equal. Here you have two sides, two angles. This is angle symbol that are congruent, and two sides that are congruent. On this one, you have three angles that are congruent, three sides that are congruent. In fact, the angles are all 60, right? That's the only one we know for sure that the angles are always going to be 60 degrees. So there's a correlation between this number of sides that are congruent and the angles, right? Angle sides. More review. Why can't a triangle have more than one obtuse angle? Right. It's already over 180, right? So let's do it this way. You need to have three angles, right? So let's say the first, do we have one obtuse angle and another obtuse angle? It's like, wait a minute. This is already 182 degrees, right? That's greater than 180. Can't be, right? Can't be. All angles add up to 180 degrees every time. So having more than one obtuse is impossible because that would violate the 180 rule, right? It would break that rule. There's no way around it. Even if you had two angles that are 90, right? Two right angles, impossible because then you would be at 180 already. What about the third angle, right? So keep that in mind. I might ask you for true and false here and there. And so this is kind of like the reasoning that you can use. Let's go and classify some triangles. Page 7. These are the steps that I would recommend. You don't have to go exactly this way. You're all going to find your own way. But here it is. Number 1, look for side lengths or angles given. It could be markings or actual values. So that's the first thing I would look at. Secondly, Can you calculate any missing sides or angles? Can you use Pythagorean theorem? Can you use sum of triangles 180? Maybe you can use sine law or cosine law, right, to help you out. So that's the second thing I would do. Try to get as much additional information as possible. The third one is your conclusion, right? If all angles and sides are different, you know for sure it's going to be scalene. It's going to be acute or obtuse scalene. We have to dive a little deeper. If you have two congruent angles or sides, I don't know if it's acute or obtuse, but it's for sure going to be isosceles. If all angles are congruent, we're done. It's equilateral. Always acute, by the way. If two angles, if two sides are the same, then you know that it's going to be two angles that are the same as well. Right? It goes both ways. Yeah. If all, here. Let's say I give you one of these. This is 4, 6, and 12, right? You're like, this looks obtuse, right? So we know in this case it's an obtuse triangle. We're done. But we know that all three sides are different. Therefore, all three angles would be different as well. So we know this is scalene territory. It would be obtuse though because of that. If I gave you one of these, and I said that this is 4, 12, and 6 like this, and you're like, what is this, right? It looks acute, but in particular, you see that all three sides are different. Therefore, all three angles must be different as well. So this would be a scalene for sure, because all three sides are different. Therefore, all three angles are different as well. So we'll go into more detail in a bit. If all angles are congruent, it's equilateral. We're done. So let's do a few examples here together. Every triangle will have a first name and a last name. Here I will go by angle. I will classify it based on their angle, and this is going to be based on the sides. Okay? And you should have on your study sheet, I will just have, by angle, I have this, acute, right, obtuse, and by side length, this, and this. Because remember, you're getting ready for the exam, right? You might forget. So here we go. Because of that, I automatically know that this is a right triangle. There's not even no discussion there. You're done. Okay? And then because of these markings, all three sides are different, correct? So this would be a scalene. This would be a right scalene triangle. And by the way, if you say scalene right, you're not going to lose any marks. You just have to get it. You just have to have these two things there to get full marks. Next, let's do this one here. First name, last name. By angle, by side. And you're like, there's no number, Mr. Jason. All I have is markings. Correct. You notice that every single angle just has one line, right? That means that these angles are all the same, which means that every single side is going to have a matching length. They're all the same length as well. So you can say this is equilateral. And because it's equilateral, we know that they're all 60, right? Normally I put it inside, but whatever. So this would be an acute equilateral. And by the way, all equilateral triangles are acute because it's always 60. You can't argue with that, right? So if you ever feel like not putting that down, I will also not take marks off because it's correct to say it that way. Okay, keep going. First name and last name. Any work you want to do it somewhere on the side, margin, give letters, whatever. I look at two sides being the same. I look at this. Boom. I know it's right. No questions about it. I look at these two markings. Because of that, I can say for sure it's isosceles. And you're like, but Mr. Dirksen, is there a chance that it could be equilateral? There could be a chance, so let's rule this out. I will just do this marking, and that told me what this was, right? You will see that there's many ways of verifying this. So let's put a letter here, A, angle A and angle B. And I will do this here. Angle A is 180 minus 90. This 90 here divided by 2. That would be 90 divided by 2. So angle A is 45. So I know this is 45. And I know this one is 45 as well. So let's say the markings had not been there, right? Just the 45s. You still can make the conclusion that the sides across from them are the same as well, since the angles are the same. So it's isosceles no matter what. Okay. Next, this one here. You're like, okay, no markings, but there are numbers. I'm going to use the sum of triangles. So I'm going to give this a letter A. So angle A is 180 minus 30 minus 20. 180 minus 50 basically, right? So this is 130. I plug this in here. And so first name, last name. Because I have one angle that's bigger than 90, this is obtuse, right? I will make an arrow coming from here. I'll say this, for right, if it's a right triangle, it's one angle that determines that. If it's obtuse, there's one angle that determines that. If it's acute, you got to look at all of them. They all have to be less than 90, right? And then this, what would this be? Scalene, right? Okay. Why is that, Mr. Dirksen? Because all angles are different. So you can actually do this. This would be accurate to say this is different than that, is different than that. All of them have different markings. Okay. So let's write this down. Scalene. I'll make a note here. All angles are different. Therefore, that's the observation I made. All angles were different. Therefore, all sides are different. I don't know if you have ever seen teachers do that, but it's just copying, right? Copy paste. Yeah, I'll put this in a bubble like this or in a cloud, just in case you're dreaming already. Dreaming of June 20th, eh? Okay. So first name, last name every time. Try to find as much information as you can and then make your conclusion. Let's keep going. I want you to try to classify these four on your own. Okay? Do some math if you need to do some math. Come up with the first and last name for all four of these. See how you do. Don't be scared. Just put it down. But if I ask you to show work, you need to show me some work, okay? So try to show. So here we go. I'm trying to think out loud for you guys, okay? That's what I'm trying to do here. I'm making a note that these two have the same marking. So I'm like, okay, wait a minute. There's a connection here I can immediately assume that this is 25 here. So I'm using red pen for what I'm adding, right? I can immediately assume that, which in turn allows me to find this one. So a letter would be great. So angle A is 180 minus 25 minus 25, right? Angle A is 130. Okay. So you put that up here. Boom. You've got lots more information now. So we know that because of that one angle that is obtuse, the whole triangle turns obtuse, right? And then the second name is by side length. We have no numbers, so you just go by the markings. And this is isosceles, yes. Because there's no, right? Like if this is 130, this side is different than the two you already have. On the other side, it would have had to be 60, 60, 60 to be equilateral, right? So there's a lot of ways of confirming your answers. Here, there's 80 there. I know that because of these markings, there's a relationship between these two, right? They're going to be the same angle. You can actually go ahead and do this, right? Those are the same. I'm going to call this BA or AB, whatever you want to call it. So watch what I'm going to do here. Angle A, which is the same thing as finding angle B, I'm just going to go 180 minus 80, and I'm going to split that remainder in half. So this is 100 divided by 2, so angle A is 50. So you know that this is 50, and so is this. And just do a quick check. 50 and 50 is 100 plus 80 is 180. Boom, you're done. And now you can name it. Based on the angles, it's acute, right? Not right. Everything is less than 90, yeah? Yeah. So I had to check this real quick, right? And then next would be based on the side lengths, there's only two that are the same, and that's guaranteed by the two angles that are the same. So isosceles. The two markings already gave it away, right? So that's it. So I had to do always. I show my work. Show my work. Right? Next. No numbers at all. So you just go by the diagram. This tells you that it's obtuse. I'll say this: no values. Right? Go by diagram and markings. Okay. That's all you have. Kind of yelling, right? No values. Go by diagram and markings. Anyways, obtuse because of that, and all sides are different, so scalene. That was easy. I want more of those, Mr. Dirksen. Give me those. There's a 90, so this is right. I'm not sure if it's scalene, so I'm going to do a quick check. If this is 90 and this is 45, let's call this angle X. 180 minus 90 minus 45. So that's 45 degrees. Oops, right? This is 45. So when you have two angles that are the same, we know that the two sides across from them are going to be the same. Okay? Therefore, it's an isosceles. Right isosceles. So do the math. If the math turns out that this is 90, 50, 40, then right, it's a right scalene. Okay? So because all angles would have been different there. Let's keep going. Ooh, time is tight. So 9 to 11 is what I would suggest you do. I will scan those and post them tomorrow. But let's go to 11 real quick. Let's go to 11. I need you to be able to sketch it using appropriate markings or numbers, whatever you want to do. Before we go, okay, I'll show you one or two examples. Acute scalene. This means all angles less than 90. Scalene means all sides are different, right? So I would recommend this. Draw me one like that. And then you make this, you go 1, 2, 3. You got rid of the scalene, right? And then I would go 60, 70. What's 60 and 70? That's 130, right? So that means that this has to be 50. And you're done. You drew me an acute scalene. Obtuse isosceles. Make it like this. I would recommend, if it's an isosceles, I actually make the obtuse angle be at the top. So I'll make that 91. That's obtuse in my books. And then I'll just do this, and you're done. Okay. You've made it isosceles. You could have done this. Watch, 91. You could have said this is 8 inches, and this is 8 inches. That is also, there's no difference. It's up to you how you want to do it. Oh, if it looks different, that's fine. Just make it look believable, right? Don't tell me, here, I'll just give you a note, don't do this. This is an obtuse triangle, right? And none of them look obtuse, right? It has to look like you could have done it like this, put the 91 here, and make these two the same. That's fine with me. So 9 to 11, I know I don't ask for a whole lot of homework, but I will see you tomorrow on this. It's going to be classifying. Okay. And I will scan the key, post it so you can make sure you understand. Thank you guys, you're great.